Okay, favorite lesson, please don't ruin it for me. I know you all won't realize how amazing this is right up off the hop, but eventually you will get to the same love of this as I do. A couple of things with proofs is we have to be super precise with our math in these. You can't do math magic. You're not going to get marks for that. So we want to make sure that we're doing appropriate math strategies on each side. So the whole goal of this is to take the left-hand side of the equation, separate it from the right-hand side of the equation in a T-chart. Do you guys remember what T-charts are? Like a table of values kind of thing. And you're going to work the left-hand side or the right-hand side or both to get to the point where they look exactly the same. So I say that with all the love in my heart, that they have to look the exact same. Then we're going to write a statement that the left-hand side equals the right-hand side. Okay? That does have to be there. That is like proper grammar for identities. You can work both sides, like I said. You can work one side. It doesn't really matter, but the math you do has to be appropriate and accurate. Format's super important, so you got to follow it so don't forget things like angle variables. That's pretty common, like you do in the question, it might say tan theta, and you just put tan. That's a half mark deduction, right? So you're going to be really, really precise on these. So we're going to dive right in. Formula sheet, super important. So we're going to start our T-chart. Left-hand side, right-hand side. So we'll start baby steps. Except I can't. So when I talk about a T-chart, that's what I'm talking about. So that line down the middle kind of becomes our equal to sign, but we're actually removing the equal to sign because we're not going to do like multiply all tops on both sides by 2 or anything like that. We have to work in isolation, the left-hand side, which is cotan theta, sine theta, and on the right-hand side, it's cos theta. So you're working these, you're either working the left-hand side or the right-hand side. You don't do it as an equation. Everybody with me so far here? Okay, we might not need our formula sheet for this one, but we'll start with that. I'm probably not going to work the right-hand side here. Anybody know why? It's basic. There's nothing I can do to it. It's not a reciprocal function. There's nothing I can do to it here. Okay? So as much as I said we remove the equal to sign, you have to still keep in the back of your mind that it is an equal sign as well there. This is the confusing part. What are you going to work on this side? Probably the cotan, right? Because that's the one that's a reciprocal function. I could write it 1 over tan, but there's no other tans in here. So I'm going to write it as cos theta over sine theta times sine theta. Every line, ladies and gentlemen, has to be equal to each other. You can't skip steps. You can't do rough work in it. It has to be every line is equivalent to the line prior. What are you going to do here? Cross out the signs. You just did your very first proof. Easy. Easy peasy.
I'm getting attention. Smile. I don't like it.
True story. I wouldn't like the smile either. All right. So now we're going to get a little bit more complicated here. Yeah. I lured you in with an easy one, and now you're going to have to do all the hard stuff. So when I was saying that a student did their identity easier than I did, it's super, like, we're all going to get there in the different ways. And what side do you want to work this time? Left? Okay, what are we gonna do on the left? Does anybody know what that is right off the top of their head? That's your Pythagorean identity. That's your Pythagorean identity. That's this one, but it's rearranged. So we have cos squared theta equals 1 minus sine squared theta. Right? We have that in our notes somewhere for 6.1. And it pops off the page to me because I've done this a million times. If it's not popping off the page to you, I think when I get my formula sheet, I would rearrange Pythagoras into this one and into sine squared theta equals 1 minus cos squared theta. If I were to get my formula sheet right away, this is what I would put on it if it doesn't pop off the page at you. I just rearrange it just so it kind of makes more sense. My variable changed. Did anybody notice that? It's x now. The other question, it was theta, now it's x. I got to make sure I'm using the appropriate variable. I can't substitute theta for x unless I make a statement about it. Okay, so I've kind of worked the left-hand side, but I'm kind of stuck here at this point. I could go back and go forward, but that's about it. Like, I can't really do too much over here. So I'm going to go to this side, and sine x I can't really do anything with. And I sometimes like to put brackets around it so I can see it a little bit better. Okay, what am I going to do here? Cross out sine. And then I have cos times cos. Left-hand side equals the right-hand side. Lesson done. We're finished. We can just walk away at this point. That's never a good sign. Just for the record, that's never a good sign. If anything, I give you guys never enough room. And when I give you a full page to do your identity, I just need you to emotionally prepare for that. Okay, so some things that makes me dread this question. Well, there's one thing that makes me dread this question. From Friday's lesson? This thing. Why am I dreading doing this? What's the problem? Adele's like, I don't know. Why don't I like this one? No, those are the angles. What do we know about cos double angle identities? I have 3 options. So thumbs down to that, because I'm going to try one, and inevitably the one I pick is always not the easiest one to do. All of them will work, but some of them will be easier than others. So this is that tenacity, like trying it, not getting the correct stuff, and then erasing it all and trying again. So here we go. I'm going to try not to cry. So left-hand side, right-hand side. Okay, so everybody's going to get the first line because it's just copying the question. I think I'm going to work the right-hand side this time because I've got those double angle identities in there. And I'm just going to leave the numerator for a second. I'm going to put in the denominator. So 2 sine x cos x. I'm just using that identity there. Sine only has 1, so I'm putting that in. Okay, let's make a life choice. And I'm going to blame it on you guys. Which one do you want to use? Pick one. 1, 2, or 3. Allie? Allie raised her hand. She gets...
Sine A cos A?
So the squares? Yep. So 1 minus, and I'm going to use brackets here because that negative is transformed throughout them. So we have 1 minus cos squared x minus sine squared x. That was just the double angle identity for sine. Sine only has one of them, so I knew that was the one we had to use because that's my only option. All right, so I'm going to distribute that negative through. Oh, I like where this is going. Okay, anybody see anything exciting in the numerator?
1 minus cos squared.
Okay, 1 minus cos squared. What is that? That's my Pythagorean identity again, right? Just rearranged. And I'm going to combine like terms.
You have to show every step of this.
Yep, you're going to die. Like a part of your soul is just going to,
Already.
yeah. I mean, I think you could have went from here to here. Like, I think that's fine. That's fine. But I need to see like what you're substituting in. You can't go from here to here. Not without losing marks. Okay, what do you want to cancel out now?
Ooh, a sine x.
Sine x. Okay, so I'm just canceling it out like that if everybody's okay with that. Because that'd be sine times sine, right? Like I could write it as 2 sine x times sine x over.
And that 2.
Right, like I could write that like this, and then I do this and this. I just get not lazy, efficient. I'm going to call it efficient. And I just take my sine x out from my sine squared. And then the 2's are gone. And what am I left with? Okay, here's the deal with this one. Some of you may be tempted to leave it here, and we know that that is tan x. But left-hand side has to look exactly like the right-hand side. So I need one more line here. I need it to say tan x.
You have to state like the
Yep.
left-hand side is equal.
Yep. Yep. That to me shows that you are finished, Tristan. That you have made a statement that you are confident the left-hand side equals the right-hand side.
Is it ever not going to equal?
No. They're all going to work. The proofs are all going to work.
Why? You know, you might
Look,
set that with their
this is, we're baby stepping into this, okay? I think that doing identities and giving you ones that don't work might be cruel and unusual punishment. All right. Okay, so what we've done so far is, Allie, that was a really good pick. That worked out beautifully. I'm glad you're in charge and not me, because I definitely would have picked a different one. This one is going to show you a different strategy. Okay? So, again, lots of room to work. You want to show as much, like, don't hide your math from me, because that's going to give you a chance of getting more marks. So don't hide the math. Okay, anybody see anything right away?
I see. Yeah, I'm like, oh,
I see a problem as well. You might think, ah, Pythagorean theorem, but it's not. Why isn't it? It's missing the squares, right? So right away, we're already stymied. I've got nothing on the page I can do. This is sine and cos. I can't make that any better. Maybe I could multiply it by a secant or a cosecant, but that doesn't look like that's going to work very much. So this is a strategy to keep in your back pocket. Difference of squares. Do you guys remember these guys?
yes.
Do you guys remember the conjugate, the difference of squares partner?
One.
Thanks, Andrew.
What is that
I
word?
appreciate it. Conjugate. So what is difference of squares? If this is one factor, what's the other factor? Plus, 1 plus cos x, right? That's the conjugate. I just call it the difference of squares partner. It's the factor that's missing, okay? If I take this, now, if I just do that, my math is incorrect. I have changed the value of the left-hand side. What do I need to do to make sure that I have not changed the value? Denominator as well. Because what's this divided by this? Has a value of 1. Anything times by 1 is itself. So when I talk about doing appropriate math, you've got to keep the sides equal in value. This is a strategy that is helpful when you get stuff that looks like the Pythagorean identity, but isn't. Okay, so if you were to multiply these, what would you get? 1 minus cos squared x, right? Or sine squared x. If you want to jump right to that, you can. I'm going to actually do the multiplying and show it in this step, just so we have full and complete notes. Okay, so if we want to do that multiplying here, 1 plus cos x, 1 minus cos x. I would do any factoring or full multiplying on a scrap piece of paper. You don't want to clutter up your identities. I just said, show me all your math, and now I'm saying, don't show me all your math. I'm sorry, having a day. But this stuff is pretty basic. It's okay if you don't remember it, or you're at the 3-hour point and you're like, I got nothing left in my brain, so I'm going to double check. And there's no shame in that, because I have definitely been there. So the whole point of difference of squares is that the middle terms eliminate each other, right? Remember, okay? So I'm going to write this out. Now I'm going to distribute my sine through here. So I'm going to have sine x plus cos x times sine x. I'm going to regret that decision that I distributed it, because I might have to pull it out later, but it's common factoring. I can do that pretty easily. So what do you think I'm going to do with the right-hand side there? Same thing, but this time I'm going to be multiplying the side by 1 minus cos. Top and bottom. Okay, I regret my decision to distribute it in. But that's okay, I'll pull it out in a second. What am I going to replace these with? Sine squared. And while I'm here, I'm going to pull that sine back out. So I've multiplied it in, then I factored it back out. This is like the bane of identities, right? The bane of proofs is that you do something and you're like, oh, that was silly. I shouldn't have done that. I'm going to unmath it. So I unmathed it. Anybody know why I unmathed it? I can cancel stuff out when I take out that factor of sine. So this will cancel that out. So I'm going to have sine x over 1 plus cos x. And on this side, I'm going to have 1 minus cos x over sine x. Okay, if there was an equal sign, things would be a heck of a lot easier, because then I could just make this equal to each other and then I could move on. So where am I going from here? Where am I going from here? Anybody have any suggestions? Do what again? The difference of squares? We can. We totally can. So if we do the difference of squares again, this one's going to be 1 minus cos x over 1 minus cos x. I really should have kept my... Yeah, welcome to my world. Well, I'm tucking into my other identity. I think we're just trying stuff out. Welcome to proofs, guys. Welcome to proofs. Did it work? Yeah, totally. We're done. We can just walk away at this point. And I think this is where the frustration comes in. And I think this is why people don't like it, because you kind of get to the point where it's like, this doesn't make any sense to me. I don't know what to do at this point. I keep going back in circles, because if I do this, I'm right back. Well, I look a little bit different. But hold on, folks. Does this look like something we've seen before?
Yes.
Yes. Did we overmath our right-hand side? Well, if we've seen it before, yes. We overmathed the right-hand side. Do you guys see that they're equal now? So really, I'm going to use my handy-dandy eraser. I'm going to get rid of that. I'm going to get rid of that. And what do you guys notice? These are the same now. I'm going to rewrite it because I think that I want it to look nice. Logan, he had faith.
I don't have faith in Logan.
I do. Everybody has been awesome with their strategies today.
Just because I'm Logan. There's no proof.
So you see how proofs can be frustrating is that you overmath something, then you got to unmath it, and then you're like, but sometimes, like in this case, we were able to see that we had just gone too far on the right-hand side. We did get them to look the same. We had just done too much math on the right-hand side. Nice thing in pencil or erasable pen, we just get to erase it, and life's good. Yep.
Do you get to write left-hand side?
Yes, still, since Tristan asked, since the last example, still we have to do it. I have faith, I have faith. Okay, that difference of squares strategy is super helpful. I don't know how you guys are gonna remember it. I don't know, get a math tattoo before the final exam or the test. I don't know if you can all get tattoos before Tuesday, but that's a good strategy to have in your back pocket.
Does clothing count?
Yes. But you know what? So a high school in Truro, like Nova Scotia, A friend of mine taught there, and for a fundraiser for the math department, they sold formula sheet shirts that had unit circles on them, and all the stuff on the front was upside down, so you could pull it out and look at it. And then the back was filled too, so just the person in the front was the only one who kind of, you always wanted somebody sitting in front of you because you could read their shirt on the back. Anyway, super cool. I do own one. Yeah, we're gonna get shirts made. All right. Okay. Why don't I like this one? It's big and it's got a Coast double angle identity in it. I'm notorious for always picking the wrong one. Actually, Logan, there's more stuff to work with, so it would be easier to manipulate. I know you were saying something inappropriate, but it did actually have some useful math things there. Oh, goodness. Okay. Cotan. You want me to slow down, but you're on your phone.
Me? I said, can you slow down? I didn't say slow down.
You did.
I was me.
Was that you?
Yeah.
Okay, I was totally blaming that on Logan, who was on his phone.
Whoa,
Whoa, why is that fair to Logan? Poor guy did some solid math today and you're beating up on him.
Calm down there, Stevie.
All right, I feel like that might be a carpentry thing that the rest of us aren't part of.
I think it's just Stevie. No, it's just Stevie. It's our best life.
Okay. Same denominator. So I'm going to have cos x minus 1 over sine x. I want to use the I want to use the difference of squares strategy here, but I'm going to stop. I'm not going to get ahead of myself. I'm just going to work the right-hand side now to see if I need to keep going on the left-hand side. So sometimes you need to pause and go work on the other side and then come back. So it's like a whole emotional process. Okay, cos double angle identity. Which one do we want to use? 1 minus 2 sine theta? Okay. So 1 minus 2 sine squared x minus cos x all over 2 sine x cos x plus sine x. Interesting. They all work. I just want you to know that all the cosines work, just some will work easier, like you'll see it, easier than others.
So you won't run into like a dead end if you pick like a hard one?
Exactly. You'll just have more math to do.
Or you'll hit a dead end.
Or you'll cry a little and just need to take a timeout. Okay. I'm looking at that denominator, and do you guys see something I can common factor out?
How'd you get that?
Oh, this is the double angle identity for that. Sometimes it's helpful if you put stuff in brackets, like, hey, that's the double identity I used for that one. Like, sometimes that's helpful. It might help you see it better. But if I'm looking at this denominator, what can I common factor out here? Sine. I can take a sine out of both those terms, right? I can common factor out a sine x. Is that helpful? I'm not 100% sure yet. On the top, I've got coses. I think I'm going to change this guy. What am I going to change him to? I'm going to use the Pythagorean identity here. I'm going to use that. I'm going to change that to that so I have all coses on the numerator. So I'm going to have 1 minus 2 times 1 minus cos squared x. So I took this and I replaced it with the Pythagorean identity. Everybody with me so far? I'm trying to go slow, but
Where'd the 1 minus 2 thing?
where did the 1 minus 2 thing come? That was the identity we picked for, so we picked this identity here to substitute in. We picked option 2. Okay, now on that numerator, I'm kind of excited. I know you guys are too. That I've got a cos squared, I've got a single cos, and then I've got a constant. So that to me right away means I can factor it. Anybody else see that? I'm going to deal with some negative signs here though. I'm going to have 1 minus 2 plus 2 cos squared x minus cos x. Anybody getting excited? No? So make sure you know how I did my distribution there. Make sure that makes sense to everybody. Like it's a negative 2 being multiplied in here, and negative 2 being multiplied in there. And then I just rearranged it. No one else is excited by this? You don't get what? What part?
Yeah.
Do you just need a minute before I continue?
Then it won't save you.
Yeah. People?
How'd you get the current denominator?
So let's go back right up from the top. The sine 2x, we just put in the identity. Okay? And then let me just take these brackets away because that'll make a little bit more sense. When I look at this, what did I common factor out? I took a sine out of both terms, which left me with sine x, 2 cos x plus 1. Okay? So I just common factored that out. Okay. Anybody excited about the numerator?
Where'd the 2 cos x come from?
Here
Yeah.
or here?
The below.
Well, because when I common factored out the sine x, when I take a sine x out of both of those, I'm left with 2 cos. Right? Okay, guys. If I have 2xy plus y, or plus x, what can I common factor out? An x. What am I left with? Right? So that's the 2y plus 1. I just common factored. That's all I did there.
Oh, okay. Never mind.
Oh my goodness. I think I'm going to need a second page for this one. Okay, good. We got a backside. Okay. I'm going to go to a scrap piece of paper because I'm going to factor this numerator. So I have 2 cos x squared minus cos x minus 1. You need to factor it. I would do my factoring on a separate piece of paper. I wouldn't do factoring within the identity. Yeah.
Do you lose marks for factoring? Or like, why wouldn't you just do it on the paper?
Just because look how much math we have, and you might lose it, Or if you won't lose marks for doing it as long as it's done appropriately. What I find though is when you're factoring it, you have to write the denominator every time through your factoring steps. If you lose the denominator, then you've changed the value of that side, and that's a full mark deduction. So just with the factoring of just the numerator, I might do it on a scrap piece of paper, just so I don't lose that denominator and lose my full mark. So that's going to be a -2. Factors a -2 that add up to a -1. So we're going to have 2 cos squared x minus 2 cos x. And this would be a place where you can substitute, like if you want to do it as 2x squared minus x minus 1. Like if you want to do it like that, if you're doing it on scrap paper, you don't need to make a statement that says let x equal cos tan or anything like that. Like doing it on scrap paper, I'm not going to see. So how you choose to chicken scratch it down is your business. So looking at these two terms, I'm going to take out a 2 cos x, and I'm left with cos x minus 1. And then I'm going to take out a positive 1 here, and I'm going to be left with cos x minus 1. And that's where I'm going to leave the factoring. Like this is my scrap piece of paper. So now I'm going to put these factors back on. I got 2 cos x plus 1, cos x minus 1, all over sine x 2 cos x plus 1. Okay, and if we look up here, it's kind of the same. It's coming together. Look at us, smarty pantses. Cancel it? Yep.
And this done. My goodness.
All right, so people struggle with this because it takes time and it takes some thought, and I'm pretty proficient with knowing my identities. Like I can see them and I have some strategies. You guys are still building those strategies. Okay, so we have one left to do. I think maybe if you're like me, we probably need to transfer it to the back side of the page, just because, I don't know, I used up a lot of the front side of my page. If you guys are still good to go there, then keep going. I just need to figure out what this is. Sine 2x minus cos. Do you guys want to try this one on your own? Whoa. Okay, what do you notice about that left-hand side denominator right away? What pops out at you? Something about it. It is a difference of squares. What do you notice about the numerator on the other side? Degree of 3. All of a sudden, those are some things that we haven't seen before. Okay, sorry, I'm just catching up to the show. You know what? You guys already have it solved? Oh, I was so proud of you. I'm gonna do the things. What? There's no denominator on the x? Oh.
No, like there's not even one in the question.
Oh, there should be. Oh. That is bad. There should be an x there. Sorry, guys. Unsolvable. Riddell's like, I'm done. Walking away. Fair.
What did that happen on test?
On the exam.
If it happens on the exam, we're going to assume that there's an x there and we're going to keep going with it.
What?
Yeah.
What if this says no X though?
It just says no x.
No, but like, it doesn't show it. It doesn't show it.
Then we're going to assume that it's there and we're going to keep going. It's not a trick. I have to say the provincial exam is, there's things that are tricky about the questions, but there's no trick questions. Okay, let's keep going with this because it's going to take us 900 years to finish. I'm going to substitute in on the left-hand side the stuff I know that double angle identity for sine, there's only one option for it. So it's going to be 2 sine x cos x, and then I'm going to have that minus cos x. What do you guys know I'm going to do right here, right away on my next line? I'm going to common factor that cos x out, right? Like, just so you know. The bottom, Tristan told us it was a difference of squares. So I'm going to do my factoring there.
Wait, what happened
I took this and I substituted in that identity. There's only one for sine, right? So I'm going to start on the sides that feel the most comfortable to me. Like, there's only one choice to make on the left-hand side for that sine double angle identity. We identified that it was a difference of squares, so I knew there was stuff that I could do right away that was kind of easy. I'm going to say easy, but it's not really easy. I'm going to factor it a cos. Anybody excited? So just doing some basic math, we've simplified it. We're going to be able to cancel these out, and I'm going to have cos x over 2 sine x plus 1. And I'm going to leave the right-hand side there. I might have to do more math to it, but I'm just going to leave it right there. Nothing is obvious. There's no obvious next step here, so I'm just going to leave it at this point. So I go back and forth between the two. When I get to a point where I'm not sure what to do, I'll stop here and work my other side. But what do you notice about this denominator and this denominator? They're the same. So I've got a good indication that I'm on the right track. All right, what are you going to do with that numerator? So that cubed, none of my identities have a cube in it. None of them do. I don't want to deal with a cube. This upsets me. So I am going to common, and it's nice, I'm going to common factor out a cos x. Oh, it's so exciting. Anybody see it? Yeah? What's that worth? 1. That's your Pythagorean identity. We never get it like this. Sine squared theta plus cos squared theta equals 1. That's it. That's all. How great is that? I would say the one that you did prior to this was harder than this one, but this one was definitely scarier looking. Okay, so that's proofs. There's no verifying. When you do a proof, you're proving that it works for all values of the variable. So it's kind of like the general solution of identities. Yeah, so I'm really excited about this. This is my favorite lesson of all times. I like it because I get to see your different types of thinking. I like it because it teaches us that mistakes are not too terrible. We can make a mistake and we can keep going.